about the maturation and activation of both the B and T cells. That's what we did basically last week, just in case you didn't make it. But now, today, our emphasis is on the recognition of microbes with regards to adaptive immunity. So now, whenever we think of a pathogen, we would actually think the entire microbe or the entire pathogen is what is responsible for activating an immune response, isn't it? But what you would actually see is that on a particular on the structure of a microbe, there is a particular portion or a particular place that is able to induce an immune response. I talked about this last week, though I'll talk about it again. You discover that on the structure, of a microbe, there are specific receptors, in short. These are regions, and I talked about them last week, and the name that we call them epitopes, or what? Or antigenic determinants. So you would find a multiple choice question where they would either bring they would either say epitopes antigenic determinants is just a particular area or a region on the structure of a microbe that is able to induce an immune response. I don't know if I've gotten that part. Have you gotten that part? Okay, thank you very much. Yeah, so another point that you must take note of is that most microbes, their surface structure is made up of proteins or peptides and or polysaccharides. It's only in some minor cases where you'd find that the structure of a microbe is being formed by a lipid and a nucleic acid response. They cannot be regarded as inducing an immune response on the same level as proteins, peptides, or polysaccharides. What am I trying to say? Proteins, peptides, and polysaccharides have, are more antigenic compared to what? Compared to lipids and nucleic acids. That's something you must take note of. It's a very important point. So now someone had asked us these questions, I think last week, and we had answered them, but I'll answer them again. What is an antigen and what is an immunogen? Usually, as what I've discovered as immunologists and microbiologists, we usually get to think of these two words, antigens and immunogens, as one as just words that can be used interchangeably. So tonight we're going to know the difference between an antigen and an immunogen. You must take note of this because you might be asked on it. It's quite very important. So what do we define or what do we mean when we call something an antigen? An antigen basically is just an agent that can be recognized by specific components of an immune response, such as lymphocytes or antibodies. And this, so an antigen bind to the what? To the specific receptor. And okay, let me repeat on that statement again. An antigen is an agent or a molecule that can basically bind to the receptors of a lymphocyte or an immunity system cell and can induce what we call antigenicity. So what does the term antigenicity mean? It is basically the ability of an antibody, if it's a B cell, or a lymphocyte just if it's just a T cell, to bind specifically to antigens. So the relationship between how would I say it? Uh, the relationship between an antigen and an immunity cell, the attaching point between these 2 points or these two cells is what we call antigenicity. So I'll give you a mnemonic of how I got to remember what an antigen is. The mnemonic I was using when I was studying this was that um, an antigen attaches to cause antigenicity. So I would call it, but the mnemonic was A to the power 3. A to the power 3. An antigen, so the first A is for antigen, the second A is for attach, and the last A is for antigenicity. You might take note of that. That's very important. So an antigen will attach. Instead of saying binding, I'm using attach, so that I can make a good mnemonic. An antigen will attach to cause what? Antigenicity. I hope you have taken note of that. I don't know if you have gotten that point. Is that point gotten? Okay. So now I'm mandated to also talk about immunogens. What is an immunogen? So an immunogen is an antigen, first of all, meaning a cell that can attach to uh, immunity cell, isn't it? And in the one use I was using for is that an immunogen is an antigen that attaches to a lymphocyte and induces a what? An immune response. So the mnemonic I was using is I to the power 3 because I'm going to talk of 3 I's. The first I is for immunogen, the second I is for induce, and the last I is for what? Immune response. So an immunogen will induce an immune response. By inducing, it means it's going to start up an immune response. So how can we differentiate the two? All immunogens are antigens, but not all antigens are immunogens. Have you gotten that point? All antigens, all immunogens are antigens, but not all antigens are what? Immunogens. So it means all those molecules that can attach to a lymphocyte. Let me say, let me say that statement again. All molecules that can attach to a lymphocyte and induce an immune response are called immunogens. But those molecules that can attach to a lymphocyte and cannot cause or cannot induce an immune response, they are not regarded as immunogens, but they're regarded as just what? Antigens. Have you gotten that point? Have you gotten that point before I continue? Have you gotten that point?
Please repeat.
Doc, can you
Okay.
kindly
Repeat.
repeat what you
Sir.
said on immunogens?
Okay, I think my phone was having some network issues. I'll use. Okay, are you able to get me?
Yes, Doc.
Yes, Doc.
Okay. Uh, Okay, thank you very much. Okay, so going back to what I was saying, hopefully now the network won't trip. Okay. Okay, so going back to what I was saying, I gave you guys a mnemonic of I gave you a mnemonic that I used myself when remembering the difference because uh, these two words are quite confusing. Okay. So now the mnemonic I used was for antigen, I used a to the power 3. For immunogens, I used I to the power 3. So take note of that because it's quite I yield. So what is an antigen by definition? An antigen can be an agent or a molecule, in other words, or a cell that attaches to a lymphocyte and it will cause what? It will bring about what we call antigenicity. And I define that antigenicity basically is just a process or the ability of a lymphocyte binding specifically to an antigen. So in other words, the F in the mnemonic A to the power 3, the first A stands for antigen, the second A stands for attach, and the last A is antigenicity. So it is basically an antigen attaching and causing antigenicity. That's the first thing you must take note of. Then I went to immunogens to be specific. What is an immunogen? So first of all, an immunogen is an antigen. What do I mean by saying an immunogen is an antigen? It means it is basically, first of all, a molecule that attaches to a lymphocyte. So when it attaches to a lymphocyte, it will induce an immune response. And when it induces an immune response, that's when you get now the issue of talking about the process of phagocytosis and other processes that we talked about some few weeks ago. So in short, what I'm trying to say is all immunogens are antigens first of all, but not all antigens are immunogens. By saying this, I'm trying to say that a molecule can attach to a lymphocyte, but it can either cause an immune response or not cause an immune response. So if it causes an immune response, you're going to call that antigen an immunogen. But if that molecule doesn't cause an immune response, then you won't call it an immunogen. You just call it an antigen like that. It won't change its name. Have you gotten the difference between these two words? So the mnemonic for immunogen is I to the power 3. The first I is for immunogen, the second I in I to the power 3 is for inducing, and the last I in I to the power 3 is immune response. So an immunogen induces an immune response. That's the mnemonic there. So it's easy for you to remember antigens for A to the power 3, immunogens for I to the power 3. Have you gotten the point there? Before I continue, I don't want to leave anyone behind because this is quite argued to what we're going to talk about in a few minutes' time. Any more questions? Or maybe I'm out of the meeting. No.
We're getting you, sir.
Forgetting you,
Okay,
Doc.
thank you. Okay, am I allowed to continue?
Yes, Doc.
Okay. Okay. Thank you so much. As I'm trying to still fix my. You're welcome, Doc. Make sure you make use of that mnemonic. Okay. Yes, Doc Kayombo.
Doc, I'm a bit confused on the
Okay.
antigen. So an antigen can attach to another cell but not cause an immune response.
Okay. Thank you for that question, Doc. Exactly. Yes. An antigen is a molecule that can attach to another cell and can either cause an immune response or not cause an immune. Okay, let me use an example of a grade 12. Uh-huh. Let's use an example of a grade 12. I like using practical examples. We were all grade 12s at one time, isn't it? We were all Sugos. Yeah, I think that's what we used to call ourselves. We were all Sugos, isn't it? But there are some people that went to university, like you guys. Those that went to university, what do you call them? You call them students, isn't it? You no longer call them grade 12 school rivers, isn't it?
Yes,
You call them
Doc.
Sugos. Yeah, you call them Sugos because they went to university, isn't it? Then um, those that didn't go to university and are still in the society, but they finished their grade 12. What do you still call them? You still call them school rivers, grade 12 school rivers.
Yes, Doc.
Exactly. So it's the same analysis with regards to antigen and antigens and immunogens. So I would think of an immunogen as as a university, uh, as a university student. Um, how would I say it? I would think of an immunogen as a university student after becoming an antigen. An antigen is a grade 12 school river. So you would either become a university student by being an immunogen, or you just remain as a grade 12 school river by just staying as an antigen. I don't know if you're able to get what I'm trying to say from that example. So
Yes.
like they all attach to the cell, but some will cause an immune response and some won't cause an immune response. The ones that cause an immune response, you call them immunogens. The ones that we will not cause an immune response. They'll just maintain their name and just be called antigens like that. I hope you have gotten the point now.
Yes, I've understood.
Okay, thank you, Doc. Yes, Doc Leonard.
Yes, my question is that for those that do not cause an immune response,
Uh-huh.
they don't have any effect to the body cells or the person. So,
Exactly, exactly. They just attach. Like they just out there. They can't activate. Um, in short, when you do antigen recognition, when we're done with this topic, that's when you understand what I'm trying to say. They'll just attach there on the structure of either the antibody or the T cell, and nothing will happen in short. But when an immunogen attaches, something should happen. That's the difference there. I don't know if you have gotten that point. Okay, I think you have. Dr. Leonard. Okay, thank you. Yeah. So now, okay, let's see. Okay, just stay on top. Okay. So last time I talked about clonal expansion. So when a T cell, yeah, okay. So when a T cell interacts with, to be specific, an immunogen, I won't be saying an antigen. When a T cell interacts with an immunogen, it means it has gotten itself exposed or it has been sensitized. That T cell will need to do what we call clonal expansion. What do you mean by clonal expansion? It means it will make more cells of itself which are able to recognize that particular a group. Let me say a particular immunogen as attached to the structure of a T cell. Then it has activated that T cell. That T cell will replicate itself and make more T cells of its kind, which are able to recognize um, a cell like that immunogen. So more of like they get educated. You educate the T cells. Remember when I talked about activation? So in short, I'm just talking about activating the T cells, then they do clonal expansion, meaning they expand themselves or they divide themselves into more of themselves, which are able to recognize that particular immunogen and which are able to give a signal to the macrophages to come and phagocytose them. Let me repeat that statement again. Clonal expansion is about an immunogen activating a T cell or a B cell, in other words, and that T cell makes more copies of itself, which are able to recognize that immunogen. Have you gotten that point? Have you gotten that point, guys? I don't want to.
Repeat what you said, Doc.
Okay. So, clonal expansion. Remember, I said an immunogen induces an immune response, eh? So, when that immunogen attaches to a T cell, first of all, that T cell, what will happen to that T cell is that it will replicate itself. I'm sure I've done DNA replication, more of like doing DNA replication. You know, the DNA does those to my. Uh, okay, someone was asking. Okay, I'll talk. You can just ask me that question that I've seen in the inbox at the end, Doc. Okay. Yeah, so going back to what I was saying, when a T cell gets exposed to an immunogen, that immunogen induces that T cell to be activated or to enforce what we call an immune response. So what is the first stage of immune response in short? The first stage is that T cell that has attached itself to an immunogen will need to replicate itself, or it will divide itself into many other T cells that will bear the same structure like that T cell, the same receptors like that T cell, which are going to be more of like developed or educated to a state where they get to recognize um, immunogens which are similar to the immunogen that activated the first T cell I talked about. So it's more of like the mother. Okay, let me put it this way: a mother, let me say, a guy has done something bad to a woman. Then that woman bears a lot of children, and teaches those children of ours to basically beat any guy that looks exactly like that guy that had dealt with that woman. That's how it works. Are you able to get the point from there? I'm trying to make it as simple as possible. Are you able to get the point from there, Doc? Yes, Doc. Yes, Doc Ayombo.
So, Doc, I'm trying to relate the piece we are talking about. I don't know if I'm ahead, but are these the ones they call the naive T cells? I mean, they are not activated yet.
Exactly. If I think I talked about it last week, I said when we develop when we form a T cell, right, or a B cell, first of all we have to mature it. What do you mean maturing it? First of all, it means it has to come out from the bone marrow, or if it's a B cell, or it has to come out from the thymus if it's a T cell, isn't it? So when it comes out of those designated areas, it is a matured T or B cell, but not an activated B cell. So a B cell or a T cell that is not activated, it is called a naive B or a naive B cell or a naive T cell. I want you guys to pay attention to those words. A naive B cell or a naive T cell. And those naive B cells or naive T cells are the ones which are induced or activated when they get to encounter an immunogen. Have you gotten that point? So when a B or T cell, which is naive, by naive it means it's not activated. It can only be activated when it meets an immunogen. I'm using the term immunogen, not antigen. I'm using immunogen because an immunogen is the one that can induce an immune response, isn't it? An antigen cannot do that. So I want to be so specific with the words. Even when you're explaining in an exam, be specific with the words. Okay. So basically, I've gotten a question, Doc, from the inbox. Which one attaches to the T cell? Which one attaches to the lymphocyte? Is it the antigen to the lymphocyte or the lymphocyte to the antigen? It can happen vice versa, but usually it's the antigen attaching to the lymphocyte. The antigen attaching to the lymphocyte. I hope I've answered your question. Any more questions before I continue? Or I can continue, isn't it? Because I haven't even gotten to what we're supposed to do. Yeah.
Yes, Doc.
Okay.
Yes. Thank you.
Okay. Thank you so much, Doc. I'm loving the questions. It means you guys are studying. I'm loving it. I'm loving it. Once I should be very careful. Okay. So now, going to what we are going to look at, the main phrase of today's meeting, what I wanted to focus on is antigen recognition. What makes a T lymphocyte to say, this is an immunogen. I've been induced to cause an immune response, or what to activate the B cell to say, this is an antigen, or this is an immunogen. This is an immunogen. I have to activate an immune response. Is what we're going to focus on today, which is antigen recognition, basically. So, what makes a T cell to say this is not just an ordinary antigen, it's an immunogen? Or what makes a B cell to say this is not an ordinary antigen or an immunogen? It is with regards to antigen recognition. The T cells and B cells have to differentiate between an antigen and an immunogen. That's how well ordered the body is made. That's how well connected the body is made. This we're talking from the cell point of view, because you won't be able to understand how a disease is formed when you get to understand how your immunity system gets to recognize that a cell or that a particular microbe is an antigen. So don't miss these basics. Don't miss these basics. Otherwise, they're quite vital. So now, you discover that B cells can recognize proteins, carbohydrates, and lipids. I hope you're getting that point, which are just on soluble toxins. Direct like that on soluble toxins. I'll explain about B cells in some few minutes, but I just wanted to give you a glimpse of what B cells can recognize. Then T cells are able to recognize peptide antigens that are bound to an antigen presenting glycoprotein. So I want you guys to see the difference between these two. B cells can recognize something directly, but for T cells, they need what we call antigen presenting cells. And I think if I just can remember nicely, I had explained on this the time I talked about innate immunity, the time I talked about what antigen presenting cells basically are and what they do. But I'll talk about it again so that you guys can solidify, because I just talked about it on this surface point of view. T cells can't recognize an antigen directly. No. They need someone to bin for them and tell them, Amu baby, this is what? This is an antigen. Check it out. This is an antigen. That's the only way T cells are able to recognize an antigen. But B cells can just recognize an antigen in the system, just like that. Remember, B cells are found where? Outside the cell. T cells are found where? Inside the cell. I don't know if you're getting the point from there. So now, antigen presenting cells, on their cell surface, all antigen presenting cells, and examples of antigen presenting cells that we have macrophages. I talked about them. Dendritic cells, I also talked about them, isn't it? Do you guys still remember these two types of cells? So antigen presenting cells, examples, macrophages and dendritic cells. These two cells, they are able to take an antigen and show it to a T cell for a T cell to determine if that particular molecule of the antigen, the macrophage or dendritic cell has brought to them is either an antigen or an immunogen. They need an antigen presenting cell. So now, on the cell surface of a macrophage or the cell surface of a dendritic cell, which are basically antigen-presenting cells, they have a structure on their body, which we call an antigen-presenting glycoprotein. An antigen-presenting glycoprotein. And to be very specific about antigen-presenting glycoproteins, we as human beings, what we have in our bodies is known as a major histocompatibility complex. For short, that word is too complex, like its name. Okay, so the name of that antigen presenting glycoprotein in human beings is called a major histocompatibility complex. For short, MHC. Other books will tell you that it is also called a human leukocyte antigen. So you just have to take note of that. I'm giving you this information so that in case you find a variety, because they'll give you the other name that you might have never seen, but I'm also giving you the other name, so you must take note of that. So an antigen presenting glycoprotein in human beings is called what? A major histocompatibility complex, MHC. And it can only be found on what? On antigen presenting cells. Mostly, if I put it that way. Okay. It can be found on all cells, but my emphasis is on what? Is on antigen presenting cells. Okay. So I'm going to differentiate on that point. So take note of that. Antigen presenting cells have an MHC molecule. So okay. So now, before I talk about the same MHC, because I've introduced them, it is quite vital for me to talk about the types of antigens. You can't go in an exam that knowing the types of antigens. So that's something you must take note of. So antigens can either be grouped in various ways. There are antigens that you can find outside the cell, antigens you can find inside the cell, antigens that can cause tumor, or antigens that can cause cancer, antigens that can cause a flu. So basically, antigens are grouped or named with different classifications depending with basically who is teaching you. So there are various ways of defining an antigen. So I'm going to explain to you the classification of antigens according to Madam Mara Mubita, the one that hopefully will be teaching you. Okay, so according to her, antigens can be grouped in, should be, I think, 3 classifications. Yeah, should be 3 classifications. The first classification of antigens. Remember, antigens are molecules that can attach to a lymphocyte and can either cause an immune response for them to be called immunogens, or cannot cause an immune response to stabilize the name of them just being called antigens. Don't forget that powerful point. So antigens can be named or grouped on the first basis or first classification, which is antigen nomenclature or antigen names based on origin. We have all done history before, if I remember nicely. In history, we used to do, I think last time I did this, I was in grade 9. But if I can remember nicely, the time we're doing Menemata Kazembe, we would do origin, expansion, and I think decline. We'll do those things when you're doing something, talking about a kingdom. You talk about where it came from, how it expanded, and how it declined, isn't it? So that's so the first type of antigen classification we'll focus on tonight is antigen names or antigen classification with regards to origin. What do we mean by origin? We're just talking about origin is just the beginning. So in other words, we're saying antigen nomenclature based on where it comes from. Take note of that. Antigen names with regards to where the antigen comes from. Like I said, some antigens can come from outside. Some antigens can just be within, inside, eating you from within. There are sometimes you can have enemies, right? You can have enemies that can come and attack you from outside. Your enemies, eh? Sometimes you can have enemies from within, your friends. They are backbiting you or attacking you from within. So you're going to know how you're going to name those your friends. Are they exogenous antigens or endogenous antigens? That's what we're going to focus on tonight. So exogenous antigens, that's the first type of antigen under the classification of antigens with regards to where they come from, or antigens based on origin. So what are exogenous antigens? The word exo means outside. We have done exothermic reaction in chemistry, I'm sure. You would say it produces a, what do you say? It comes out, Chan. Yeah, all those points. So exo means outside. Exotic meaning something coming from outside. Exo, outside. It sounds so outside, like exit, exo. So even your X outside, you're seeing the ex there. So exogenous antigens are all based on antigens that come from what? From outside of the body, which are basically regarded as foreign. They come out outside the host. Basically, you're the host of that antigen. They're entering inside your body. Antigens that you can find outside the body. So there are some antigens that you might just get from smoke, some antigens that you might just get from maybe from touching something, from sweat, from body fluids. Antigens that come from outside the body are regarded as what? Exogenous antigens. Take note of that. So now, how do those antigens find themselves inside the cell? The only process that these antigens exactly, the only process that you find this antigen entering your cell is by a process known as phagocytosis. What do you mean by phagocytosis? It means when that antigen enters your cell, let me say it enters the body from outside, you have more of like maybe it was part of your food that you ate, then that antigen has to be killed. In what way do we kill exogenous antigens? Usually they are killed by a process known as what? Phagocytosis. And usually phagocytosis is done by a particular type of cells, which are the APCs. In other words, the antigen presenting cells. I don't know if you guys have gotten note of that point. Remember, we had said the APCs have to go and tell the what? The T cells, have to go and tell the T cells, no, we have been attacked. So how can they tell the T cells? They can only tell the T cells if they have an evidence of saying this is the type of antigen that came from outside that we have killed. So the only way that the T cells are able to give evidence to the only way that the antigen presenting cells, the APCs for short, are able to show the T cells that this is the antigen I caught is by first of all the APCs themselves phagocytosing, meaning ingesting that particular exogenous antigen. After ingesting it, they get to present it on their structure. When they present it on their structure, they go and show the T cells. That's when we get to talk about what we call an immune response. Have you gotten that point? Have you gotten that scenario? Have you
No,
gotten
repeat
that
what you
scenario? Okay, so I was saying exogenous antigens come from outside, then they find themselves inside the body. Again, they're inside the body. What happens? The macrophages and the dendritic cells have seen that this is an antigen. What do? They will go and ingest it. Ingesting, we don't call it ingesting with regards to immunology. We use a better term. We call it phagocytosing. They get to phagocytose that particular antigen. When they get to phagocytose that particular antigen, I'm taking you back to the first topic we did. So I'm trying to explain the process of phagocytosis. So when they ingest that particular antigen, that's called phagocytosing. When they ingest that particular antigen is going to go to the lysosome of that antigen presenting cell. For example, in this case, I'm using a macrophage. When that antigen goes to the lysosome of that particular macrophage, it will mix with the chemicals of that macrophage. When the macrophage, when the chemicals of the lysosomes of that macrophage mixes with the antigen, they'll form what we call a phagolysosome. You're getting the point, huh? When they form that phagolysosome, that molecule will be metabolized more, and after it has been metabolized more, it will be expressed outside the structure of that macrophage. And when that antigen, that metabolized antigen, has been excreted outside on the structure of that macrophage, the macrophage can now go to the T cells to go and present that particular metabolized antigen as evidence to the T cells of saying this is the antigen I've caught. You have seen, I've even killed it, meaning there are a lot of antigens out there. So you the T cells, recruit more other T cells, recruit more other macrophages, so that we go and fight that particular antigen. That's the process of antigen presentation and phagocytosis. Have we gotten? Are you getting the picture of what I'm trying to give you guys? Have you gotten the picture, or maybe you're still not getting what I'm trying to say? Aren't you
Yes,
guys
Doc,
get?
we have.
Okay, thank you. So now there's something that I didn't say. I only said they get to express that metabolized antigen, isn't it, on their structure? So now the question I expected you guys to ask me is, how do they express it, or in what molecule do they use to express that particular antigen that has been metabolized? So they use a particular or a specific molecule known as an MHC. Yes, Dr. Leonard, known as an MH. Let me just finish up a bit before you come in. Okay, so they use a specific molecule known as an MHC class 2. So all macrophages have a specific MHC molecule. So there are basically 3 types of MHC molecules that you would find in immunology. But for your level as a medical student, you only be taught 2. That's MHC class 1 and MHC class 2. They won't teach you the third one. Though I myself will tell you about the third one, but you won't be asked on it. I'll just tell you so that you guys should know about it. So MHC class 1 and MHC class 2 are the main ones that we talk about in immunology for medical students. So now we're trying to look at MHC, the molecule. I hope you guys still remember MHC. I talked about this a few minutes ago. I said MHC, which basically stands for major histocompatibility complex, MHC for short, is what antigen presenting cells would use to give as a signal to the T cells to tell them that this is the antigen I've caught. So it's more of, so basically the spoon or the fork that the MHC molecules use. I'll use an example. I'm sure we avoid. I hope we avoid like siblings. Then they give you a sibling. They give you, let's say, example of porridge. They give you porridge. Then you think of yourself as a macrophage. Then the spoon that you have to get. So let me say it again. So there are 4 things we're going to talk about. You, the elder sister or elder brother, a spoon, porridge, and the child. So you, as the elder brother or elder sister, you are the macrophage. The spoon is the MHC class 2 molecule. Then the porridge basically is the antigen, the metabolized antigen. You know you have to cook porridge before you feed the child. So you have to metabolize the porridge, cook it nicely. So the porridge is the metabolized antigen. then your kid sister or kid brother becomes the what? Becomes the T cell. So you, the macrophage, you use the spoon to get the porridge, which is the antigen, and you feed it to your sister or your brother, which is the T cell. That's how the process actually works. Have you gotten the point from the way I'm talking about it? So the MHC class 2 molecule is the spoon in this case, in this example I'm giving you guys. Are you able to get the analysis from there? Hello? I might be out of the meeting, huh? Hello?
Yes, Doc.
We can get feedback.
Yeah, okay, thank you so much. Okay. Any questions so far? Yes, Dr. Nad, you had the question? You had the question? You had the question?
Okay, yes, I had it, but at
Yes, Doc.
least when you explained, you partially answered it.
Okay.
But I think what I've just remembered is uh, I wanted to know what the antigens are presented on. Now you say the so then on the T cell, is it supposed to just differentiation for that recognize MHC, MHC, sorry, MHC.
Okay, so on the structure of the T cell also has some structures on its body as well. I think I talked about T cell receptors last week, isn't it? I hope you guys still get you got just you can remember that, but I think I remember saying something like that. Um, T cell receptors also T cell receptors are found on T cells, eh? So they also get to use those the structure on themselves, the T cells, to get to recognize what the antigen presenting cells, in this case the macrophages, are more of like showing to them. Yeah. So okay, I'm sure I'll answer your question fully when when we continue with the discussion. Yeah. I don't know if I've this answered it partially. Yeah, but I'll continue answering the question as we are going. Okay. Thank you. Okay, so now continuing to what I was saying. Okay, so under exogenous antigens, we're talking of antigens that are coming outside of the body of the living organism, isn't it? So there are some examples of exogenous antigens that I'll give you guys. We have what we call bacterial antigens. These are antigens which are bacterias in short. Those are bacterial antigens. Then we also have what we call antigens which are formed of the bacteria. No, bacteria do secrete molecules, though I'll explain to you guys in details when we do microbiology. Hopefully this one will work out. If it won't, I just hope it will work out. Yeah. So that I won't have to do a makeup. Yeah. Okay. Are you able to see the screen, isn't it? No. Can I get a feedback so I should know if I should continue?
Yes. Think
Okay. Thank you so much, Doc. Okay, so I think if I can recall nicely, I said exogenous antigens are antigens that come from outside the body, isn't it? Then I also said we have examples of exogenous antigens, and to be specific and to give you examples, I talked about the first type I talked about was bacterial antigens. And with regards to bacterial antigens, I said bacteria can either produce toxins or enzymes that will be regarded as antigens or immunogens for the for the immunity system, or just on their structure. If you remember when we did innate immunity, I talked about when I talked about the PRRs, I said the PRRs are able to when they just touch the structure of a bacteria, they're able to find some special parts of the bacteria that would make the innate immunity system to say this particular molecule or cell is a bacteria or an antigen, in other words. So bacteria have two things that causes antigenicity and immunogenicity. The first thing is the structure or their morphology or their makeup. Then the second thing is the products that they produce. You understand this better when we talk about virulence, the time that we'll be doing microbiology. Don't worry, it's just in some few weeks' time. You'll appreciate this data nicely. I was just giving you guys on a surface point of view. Then the second thing that we would regard as an exogenous antigen is viral antigens, from the word viral. I'm sure you would notice that we're basically just talking about what? About viruses, isn't it? So viruses basically are regarded as they also have two things on that they either produce or that is on their structure that makes it antigenicity, or that makes them to cause antigenicity or immunogenicity. So the first thing is that the way they are formed, their morphology as well. They have what you call protein coat around their structure. That protein coat around their structure can cause the immunity system to think of them as what? As antigens. Then the second thing is that they have also products that they can also produce at the same time, which the body can also recognize as what? As products of an antigen. Okay. Any questions on antigens before I go to the second type of antigen? Any questions? We move? I might be talking. We move? I don't want to leave anyone behind. We move?
Repeat.
Okay, so I said with regards to, I hope my voice is audible. I was saying exogenous antigens that you'd find outside. Examples of those antigens that you can find outside. The first type or the first example is a bacteria, and the second example is a virus. So a bacteria can be regarded as an antigen because of two reasons. The first reason is that the way it is, the structure or the components that are on its structure can be regarded as antigen. The second thing is that it produces substances like enzymes or bacterial toxins, which I will explain better when you do microbiology. These two things, the structure and the secretions, cause a bacteria to be regarded as an antigen. I also went to a virus and said, when you look at a virus, its structure as well, it's the way it's formed, its structure as what we call a protein coat around it. And it also produces or secretes some specific substances, which we'll do next year under virology in microbiology. When you talk about the secretions, it secretes those secretions and its structure as well would the innate, both the innate and the adaptive immunity would regard that molecule, which is a virus, as an antigen. I don't know if I've managed to make you guys understand so far. I can proceed, eh? I can proceed and not repeat. Can I proceed and not repeat? Or I go on part time? Okay, thank you.
Proceed and repeat.
Okay, the second thing is yes, Doc. Yes, Doc Narukai. Naruki.
You can proceed, sir.
Okay, you need to tell me how to pronounce your name correct. I'm sure I'm making a lot of mistakes. I'm very sorry, Doc. Okay,
Narukui.
the second thing, Narukui. Okay, Narukui.
Yes,
Try to
Doc.
memorize it. Okay, I'll make a mnemonic for it. I love mnemonic so much. Okay, the second thing is the second type of antigens that we have are what we call endogenous antigens. Endogenous antigens. Indo. It even sounds inside, eh? Indo. Mm. You can use it as a mnemonic option. Indo. So a mnemonic on its own. Indo. Where do you find the door inside? Eh? Indo. Okay, so an endogenous antigen is basically just an antigen that you would find within the body of that particular host. Then the difference also with regards the difference between an endogenous antigen and an exogenous antigen, apart from the location to which it comes from, is also the fact that endogenous antigens, they are presented to the T cells using a different type of MHC molecule. Remember, I talked about MHC class 2I for exogenous, but for endogenous antigens, they are presented using MHC class 1 molecule. MHC class 1 molecule. Take note of that, and I'll explain to you what MHC molecule is. Okay. So they are presented using what? MHC class 1 molecule. So now, something that is unique about antigen presenting cells, I was waiting for this moment, is that antigen presenting cells themselves contain two types of MHC molecules. So the only type of cells in the human body, as far as I know, unless if you discover another one, but the only types of cells in your body which contain both MHC class 1 and MHC class 2 molecules, they are the antigen presenting cells. This includes the macrophages and the what? And the dendritic cells. So why am I saying the only cells? What about other cells? What about other ordinary cells of the body? What about if someone was to ask, what about the basophils? What about the eosinophils? What about other cells that you have ever heard of from the time you are born? So all other body cells that you have ever heard of from the time you are born, they contain only MHC class 1 molecules. They contain only MHC class 1 molecules. But the APCs, the antigen presenting cells, contain both MHC class 1 and MHC class 2. That's something you must take note of. Very important. So it means for a cell that is inside your body, for it to be regarded as a cell of your human body, it has to have it needs to contain an MHC class 1 molecule on its surface or structure. Hello? Okay, that's not the question. So why do all cells need to contain MHC class 1? I'll tell you two reasons, which I'll come back to in few weeks from now. First reason is that we have the NK cell. You get it? The NK cells recognize molecules or cells to be either self cells. By self cells, I'm talking of cells which are part of your body, or normal cells in short. Let me talk of liver cells. The NK cells, why do you think NK cells don't attack your liver cells? Or why do you think they don't attack them? Why do you think your NK cells don't attack your lung cells? It's because your lung cells, your liver cells, they contain MHC class 1. So NK cells, when they look at the surface structure of all body cells, they look for MHC class 1. So if they find MHC class 1 on that cell, they'll recognize that cell as a normal cell. You get the point, eh? So what's the other point? I said there are two reasons why. The other reason is that when you talk about tumor cells, or when you talk about bacteria, they have no MHC molecule in their structure. That's why when the NK cells come and test it or check its structure, they don't find anything. Just talk. Am I audible?
Yes, Doc.
Yes,
Okay.
you're audible, Doc.
Okay, thank you. So when the NK cells touch bacterial cells, bacterial cells have no MHC molecule in their structure. So it's more of like when you're coming from Karingaringa, then you want to enter Unza main campus. Yeah, I doubt if they do that at PGA. But when you enter Unza main campus from Karingaringa, you usually find the what do you call them? Unza what? Okay, I don't know, but let me just call them security. The security guys that would find at the gate when you're coming from Karingaringa, when you're about to enter Unza. Those guys, what do they ask for? They ask for what? For what? For your Unza ID, isn't it? So the Unza ID they ask for, with regards to immunology, that Unza ID acts as MHC class 1 molecule. So when the NK cells, which with regards to the example I'm giving you, the NK cells are like the Unza security. The NK cells, the Unza security wants you for your MHC. Then you can't present your MHC. So since you can't present your MHC, you'll be regarded as a student who is not from Unza. You'll be regarded as a student who maybe is coming from Creso, from Review, or somewhere else. So you're a foreign, basically you're a foreign a student. And with regards to immunology, would say you are a foreign what? A foreign cell, or you are an antigen or a bacteria, in other words. I hope you're able to get the way I'm trying to relate immunology with what we do due to day-to-day activities. Yeah, so that's something you must take note of. All body cells possesses MHC class 1. But only antigen presenting cells possess MHC class 1 and class 2. So why from when a cell misbehaves, when a cell misbehaves, it's going to lose its MHC class 1. So what molecule is the macrophage will come and get that particular cell, phagocytose it, but they won't present it on the MHC class 2. They'll present that macrophage, so they'll present that microbe on their what? On MHC class 1 molecule. So that they go and indicate to the T cell and tell them that this antigen I've brought to you did not come from outside. It's an antigen that came from what? From within. You get the point, huh? Are you getting the point? That's the reason why those guys from Unza what? Unza security ask for your ID card. So that when you enter inside there, in a case where you're a thief, you're stealing your friend's clothes, when you steal, and the Unza security catch you, they'll go and present you to the police as what? As an Unza student who is a thief. I don't know if you're getting what I'm trying to say. Because they have already identified you as an Unza student, but you're a thief. So they will try to differentiate you from a Creso student in the beginning by asking for your ID. Once you're recognized as an UNZA student, then when you're found stealing, you will be taken as a thief who is from UNZA. I hope you're able to get. Okay. I can't get you, Doc. Is that a question for me or maybe just a mic? Okay, I already talked about the other name for MHC. You can call them human leukocyte antigen. Yeah, so you can take note of that. Okay, that's all you need to know about Indo antigens. There are also what we call, there's also what we call auto antigens. What do we mean by auto antigens? In a case where immunity cells, you know that the funny thing that some macrophages, let me just put it out this way. There is a topic we'll do autoimmunity, but let me give you a briefing. In some cases, immunity cells can misbehave, right? They can perform. They can start fighting normal body cells. And when they start fighting normal body cells, okay, when they start fighting normal body cells, those innate, let me say, those immunity cells which are fighting normal body cells will be regarded as autoantigens because their main function was to fight what? To fight microbes. When they start fighting, they are the normal body cells. So would call them autoantigens. Auto means same, right? Same. That's an automatic thing. Same, like same coming from within. Auto. Auto means same. Okay. The other type of antigens. So I've talked about three types of antigens. Exo, endo, auto. I'm not talking about tumor antigens. So what are tumor antigens? So tumor antigens, also called neoantigens, are just antigens that can cause what? That are found on tumor cells, in short. That are found in tumor cells. That are found on tumor cells. And usually they are not immunogenic. What do I mean by immunogenic? Mostly the tumor antigens do not cause an immune response. When you do tumors, you understand why. Why don't they cause an immune response? If I start explaining it, I'll enter another topic. So let me just leave it there. So write it down so that you can ask me why the time we do tumor antigens. Okay. Then the last type of antigens we'll talk about is what we call native antigens. These are antigens that are processed by APCs and basically are what? And cannot directly bind to the T cells. Remember, I said when an antigen binds to a T cell, it will be regarded as an antigen first of all before it causes an immune response. But in a case where the T cell is not the first thing that bounded to that antigen, let me say the antigen came from a macrophage. That macrophage is regarded as that antigen is regarded as a native antigen. But not very important for you guys. We'll already be asked on it, but I just wanted you guys to take note of that. It's quite important. So that's there are five. So in short, in conclusion, there are five um, types of antigens with regards to where they come from. So always take note of that. Always take note of that classification. Endoantigens, exoantigens, tumor antigens, native antigens. What else did I talk about? There should be five. Okay, auto antigens. Forgot about it. Auto antigens. So take note of that. A quiz will be asked on that. I have a quiz for you guys on that. A second type of classification of antigens is antigens based on on the immune response. Does this antigen cause an immune response or doesn't cause an immune response? He said when an antigen causes an immune response, what do you call it? An immunogen. So now to understand this context successfully without having any issues, itself just it can cause an immune response. I hope you're getting that point. So some of the notes or some of the points I talked about this last week, but I'm just trying to make you guys revise through it. What are some of the points that make an antigen immunogenic? The first thing is the size or the molecular weight. For an antigen to be regarded as an immunogen, it has to weigh more than 10,000 Daltons. 10,000 what? Daltons. Take note of that. And the other thing is that for it to be regarded as a complete antigen or an immunogen, it has to be either a polysaccharide or a protein in nature. Why? Are we saying it has to be a protein or a polysaccharide? Because these molecules are regarded to be complex. For a molecule to be regarded as an antigen, it has to have a complex surface structure. You can't have it. You can't just have it so simple, lipid, direct to the point. Nucleic acid, direct to the point. It has to have a complex. Polysaccharides are complex. I'm sure you're doing biochemistry. I don't want to enter into biochemistry, but you have seen how those structures when they're naming them. Even the name itself is so complex for you to understand. Alpha 1, shan 4 8 shan. Those are big names. So it's so complex even for a student to understand the nomenclature. What about immunity cells? Even them, it's so complex for them to understand what it is. So if it's made up of a complex structure, then you regard it as a what? A complete antigen or an immunogen. And also, they do not need what we call carrier particles. We don't need on itself, just on its structure, just it can cause an immune response. It doesn't need other molecules to be added to its structure to make it more immunogenic. That's something about complete antigens, or sorry, complete immunogens in short. Then the second type, I think this is the last type, is the incomplete antigens, and they are also regarded or also called as aptens. They'll ask you questions on this. I doubt if an exam can end with that aptens. What are aptens? So when a molecule is a partial antigen or is a partial immunogen, in other words, meaning it needs something else for it to be an immunogen. It needs something else for it to cause an immune response. You call that molecule an apten. I hope you're getting the point. It has to be added with a carrier protein on its structure for it to be to be immunogenic. Examples of okay, how would I say it? What are some of the characteristics of a molecule to be regarded as an apten, or in other words, an incomplete antigen? The characteristics are: it should have a low molecular weight. By low, it means it has to be less than 10,000 Daltons. Remember, I said for a molecule to be a complete immunogen, it has to have a molecular weight of more than 10,000. So if it's less than 10,000, then it's a partial antigen or an incomplete antigen, in short. So you discover that all molecules with that which have that molecular weight that is less than 10,000 Daltons are regarded as what? As incomplete antigens, or in other words, aptens. So how do you make an apten to become a full complete antigen, or to become um, an immunogen, in other words? So you get this apten. I hope you're able to see my cursor. You get this apten. You add it with a carrier molecule. Examples of carrier molecules are protein. Okay. Examples of carrier molecules are proteins, polysaccharides. Remember, I already said proteins and polysaccharides are so complex. So you get that apten, right? And surround it with a complex molecule around it to increase its complexity. I don't know if that word exists, but complexity, okay, to increase its complexity, and also to increase its molecular weight, in other words, for it to become a full complete antigen. This is what actually happens in the body. Then the body is it's a book of its own. It's a book that you get amazed every time you check it out. So an apten will react with a what? With a carrier molecule, preferably a protein or a polysaccharide to make it a complete antigen. You see what is happening? I've added this to my aptens with it's a big thing to make up this molecule there. After guys are getting this point, very important. Very important. So that's classification with regards to how immunogenic a molecule is. So the last type of antigen we'll talk about are what we call super antigens. What are super antigens? These are just antigens that can activate multiple clones of T lymphocytes. When they bind to a particular part of a T lymphocyte, that's the B chain of the T lymphocyte receptor. So if I remember nice, I said the T lymphocyte receptor has two things. Either have an alpha or a beta chain. But when a super antigen, or let me say when a molecule goes to sit on the B chain of the T lymphocyte receptor and activate it to form a huge number of clones. Initially, yes, it has to form clones, but when the clones are just too much or a lot, basically, we would call that molecule a super antigen. Think of it. Super just means something supernatural, something out of the ordinary. It's just something out of the ordinary. So, in short, we're saying when an antigen forces a T lymphocyte to make a lot of clones of itself, that antigen is not called just an ordinary antigen. It's a super antigen. Think about it in such a way. That's basically something you need to take note of. Okay. Yeah, so I already talked about some of the characteristics that make a molecule an antigen. I said it has to be foreign, meaning it has to be outside, or then it's not a normal. It's not regarded as a normal thing. Remember, all normal cells have MHC class one. Then there comes a molecule that has no MHC class one. It will be regarded as an antigen. The molecular size, I already said a molecule has to be above 10,000 Daltons to be what? To be regarded as a what? As an antigen. The chemical structure and complexity. I wonder why this word is so hard for me to pronounce it. Complex and data. Okay. Complexity. Yeah. So now we're saying when a molecule's structure is so complex, it will be regarded as a what? As an antigen. Also, we talk about okay, not so important, but then I talk about it. The route in which that a particular antigen or that particular molecule enters. You discover that molecules that enter through what we call parental routes are more immunogenic than oral routes. What am I trying to say? Oral routes are basically antigens that enter from the mouth. Then parental routes, I'll give you examples of parental routes, or routes in short, of, of, of a way an antigen can enter the body. So we have what we call subcutaneous, we have what we call intradermal, we have also, in short, a molecule that doesn't enter from the mouth is more immunogenic. Why? Because when something enters from the mouth, it means you need to go through the GIT. In the stomach there you'll find acids. So it can either be cured from the acid that you'd find in the stomach, or it can basically be cured faster through maybe the small intestine, because you'd find the immunity cells in the small intestine. But when a molecule enters through, for example, subcutaneous routes, so enters through intradermal routes, or intravenous, in other words, basically. I'm talking about a molecule entering directly in the blood. So it is more immunogenic when it enters through the blood, because it can attach to a T lymphocytes faster than the ones that would enter through the mouth. In other words, yeah. So that's something you must take note of. So what's an adjuvant? What's an adjuvant? So let me take you back to this diagram. Right? Remember, I had said an uptake has to react with a carrier molecule. An example of a carrier molecule is a polysaccharide protein. So an adjuvant is a molecule that you would add to a partial antigen to make it more immunogenic. You're getting the point, eh? So this carrier molecule is an example of an adjuvant. Have you gotten that point? So what you add to something to make it more immunogenic is just an adjuvant. So I've talked about many terms, but don't forget uptake, don't forget adjuvant. So in short, the mathematics is as easy as that. I'm going to do math. Don't love math, but I'm going to do it on immunology right now. An uptake plus an adjuvant will form an immunogen. An uptake plus an adjuvant will form what? An immunogen. Simple mathematics of immunology. That's the best mathematics you ever find. No need to differentiate or integrate. Just an uptake plus an adjuvant will form what? An immunogen. Do we have any questions on that? Any questions on that? Doc David, is that a question? Doc David, is that a question? It's not. Okay. To finish up on today's just to finish up on today's meeting, I know I've talked a lot about stuff, but at least I've gotten much of the context. I want to finish everything about adaptive immunity by talking about MHC molecules. Okay, I'm also tired as well, but I just have to finish up this because I doubt if I'll find time to come and talk about this. So important, yeah, so important. And the good part is that it's been recorded, so you guys can still come back and watch it at any time. So MHC molecules, very important things for you guys to take note of, or to note, or to know. There are two types of MHC. I try by all means to simplify them as easy as possible. MHC class 1. Where is it? MHC molecules are found on chromosome number 6. I'm sorry to take you back to bar 140. Okay, you guys never did 01 or 1412. Just did 1400. I don't know why you just did 1400. I'm not sure if all of it has been recorded, but I don't know. Okay, I'll confirm with you after the meeting is done. Okay. Yeah. So taking you back to bar 1400, we did chromosomes, as far as I know, isn't it? You did 1400, isn't it? Or maybe there's some that did 1412 and 1401, or maybe 1312. I don't know. But anyway, let me just go to what I want to say. So bar 1400, I told you about a chromosome. A chromosome as when you look at the structure of a chromosome, just get one. Do you call it a strand? Okay, let me call it a strand, but it shouldn't be called a strand. It should have another name. A chromatid. Here, that's the term I was looking for. You get one chromatid. It has two places, three places, There is the first part. Okay, in short, it has mainly two places. There's the middle part. We call it a centromere. Then the last part we call it the telomere, isn't it? Centromere and telomere. So on chromosome number 6, to be specific, you guys, how many chromosomes do you have? I've forgotten. Someone to remind me. How many chromosomes do we have?
46.
46, huh? Okay. Yeah, 46. So to be specific, on chromosome number 6, when you get chromosome number 6, on the structure of chromosome number 6, that's why we get the coding or the formation of MHC molecules on chromosome number 6. Take note of that. So on chromosome number 6, that's why we code for MHC molecules. So MHC molecules are found on 3 parts of the chromosome number 6. It's unfortunate that I have no structure of chromosome number 6, guys, but hopefully you'll be making a picture from my voice. So I want you to label the parts of chromosome number 6 in this way. The first Okay, you can just do, if you're writing somewhere, you can just break a line. Yeah. So when you break a line there, the first part, meters 3. Usually that's why you'd find MSc class 3, the one that is really talked about. On point number 2, that's why you would find MS, on part 2, that's why you find MHC class 2. On part 3, that's why you find MHC class 1. Have you gotten that point? I'm telling you how MHC is coded on chromosome number 6. So I said you draw a line. The name is 1, 2, 3. 1, 2, 3. So on part, I think one mic is on. Are you able to turn off your mic though? So on you find the coding of MHC class 3, the one that is there I talked about. On number 2, you find the coding of MHC class 2. On number, so 2 for 2, eh? Okay. On number 3, you would find the coding of MHC class 1. So MHC class 2, the coding is designated or is named as HLA. HLA stands for okay, let me just go on class 1 first of all. So on class number 1, remember class number 1 is what we named as 3, isn't it? On the diagram I was making you guys draw in your mind. On number 1, which is 3, the nomenclature of how it is or how the coding happens is with regards, the naming is human leukocyte antigen HLA A, B, and C. Take note of that. On part 2, which is the centromere, centromere meaning the middle part of the chromosome. That's how you find MHC class 2 coding there. And on that one, what basically happens is that the nomenclature is let me see if okay, the nomenclature is okay. The nomenclature is with regards to letters. We have DP, DQ, and DR genes that you'd find there. So these are just basically genes that code for these MHC classes, either MHC class 1, class 2, and class 3. So what about class 3? So the funny thing about class 3 is that class 3 just comes to help in this way. If we have made few MHC class 2 molecules, class 3 will come and help with making more MHC class 2 molecules. In a case where we have made few MHC class 1 molecules, MHC class 3 will come and help with making MHC class 1 molecules. Take note of that. Just making you guys get the full points on that one. So I already explained why you'd find MHC class 1. You'll find it on all normal body cells. Then its structure looks like this. It has, so think of this part I'm showing it down. This is the body of the macrophage. Then this castic you're seeing is called a transmembrane protein. It's the one that connects for example, the macrophage to the MHC class molecule. And this MHC class molecule is regarded as MHC class 1 molecule. So one thing about MHC class 1 molecule is that it has 3 alpha segments. That's alpha 1, alpha 2, and alpha 3. And it has the fourth part, which we call a beta microglobulin side. So now I'm going to explain to you what all these segments, what all these 3 segments, how they work. I want to tell you about their molecular weight. I think for intake it's not that for what for medical purposes, for medical students it's not that important. We'll leave it for microbe. How do you call them again? Medical biochemists, biomedics. Yeah, you need for biomedics to know. But I could have told you, but it's not very important for you, not very high yield. Okay, so now A3, A3. This is a part. The A3. This is basically the part. Let me show you this side. Okay, let's talk about it. Okay, on A3, this is the part where the CD what? Okay, so on A3, this is the part where the CD8. I think I told you that there are two types of T lymphocytes. They are what we call so there are two types of T helper cells. In short, we have T helper cell that has the name of CD8 and CD4. So CD4. Okay, so CD4 go for MHC2, but I'm dealing with MHC class 1. So the one that the types of T cells which bind to MHC class 1 are CD8. And where do they bind from? They bind from the alpha 3 subunit of the MHC class 1 molecule. Take note of that. Then what's the function of this part? I'm sure I've seen this part, or am I the only one seeing it? This empty part looking as if you want to put, maybe you can put a pot there, you can boil some water there or some chunks there. So this part here, it's a part where we put molecules here, and the number is, it can possess 8 to 10 amino acids. So meaning when we're presenting bacteria, 8 to 10 bacteria can fit there. It's so big, that point. So that's something you need to know about MSc class 1. So to summarize and to finish up everything, I'll go to MSc class 2 and explain it like the way I talked about this other one. So MSc class 2, I hope you guys are able to see the difference in structure. I'll bring for you this diagram. This is class 1. It has three things, right? Alpha 1, alpha 2, alpha 3, and beta microglobin. But when you go to MSc class 2, it has alpha 1, beta 2, and alpha 2. I hope you're able to see. The difference is that for MSc class 2, the type of T cell, in fact, the other thing before I go to the type of T cell, is that it also has two transmembrane proteins. Okay, so 2 for 2, right? Remember ukozeka one, where it had a one, like I had said, I love the morning so much. I remember things when I put it in the morning. So MSc class 1 have one transmembrane. So 1 for 1, one for transmembrane. But then when you go this side, MSc class 2, 2 for 2, it has two transmembranes. So that's why it's called MSc class. Okay, it's not the reason why it's called class 2, but that's a mnemonic for me. It has two transmembrane proteins. So take note of that. So where do you find class 2? You can only find the class 2 in what? In antigen presenting cells. Remember, antigen presenting cells contain both class 1 and class 2. And class 2 is only found on antigen presenting cells. So this is an example of macrophage. In other words, for class 1, I can say this molecule can either be a liver cell, a brain cell, doesn't matter. As long as it's a normal body cell, it can possess a class 1. But this structure, until you die or until you discover another one, it can only be possessed by a macrophage or a dendritic cell. And it has also some good parts. Like I said, the segments is alpha 1, alpha 2, beta 1, beta 2. So alpha 1 and beta 1 are what makes up the component that receives the amino acids. And how many types of what's the number of amino acids that you can receive? So this one is bigger than what? Than an MSc class 1. This one can possess 13 to 18 amino acids. Look at how big it is. That one could possess, it comes in multiple choice. So know the difference. This one possesses 8 to 10. The other one is what? 13 to 18. You get the point? So you must take note of those numbers. microbe, isn't it? But with regards to the MSC class 2, it's alpha 1 and what? And beta 1. So never forget that difference. Very high yield, no matter what you do. You can forget everything, but never forget this point. This point. This an exam, a full exam can come from this topic. Take note. Now, what about beta 2? Why do I need to talk about beta 2? Remember, I had said alpha 3 is what alpha 3, yeah? Alpha, I hope you're able to see alpha 3. Alpha 3 is what odds a T cell, which is a CD8 T cell, right? Remember, I said CD8 T cells are also called what? Called what? Cytotoxic T cells, huh? So cytotoxic T cells, also called CD8 T cells, will bind to alpha 3. But CD4, also called alpha T cells, just generally like that, bind to beta 2. So there's alpha 3 and beta 2. Very high yield points. No matter what you do, never forget those points. So those are some of the differences between MHC class 1 and class 2. So when a T cell, so when they bring a macrophage, they'll go and attach it to a the T cell will audit from this point, the beta 2 or the alpha 3, depending with the type of T cell you are basically dealing with. I've already talked about the process of phagocytosis and how it happens. This is I didn't realize that there's even like a picture here for you guys to see, but this is what I already talked about. This is how a peptide will go there on the structure. Okay, then yeah, okay. Yeah, so basically that's what you need to know with regards to MHC class molecules. Yeah, so just something that I didn't talk about that I want you guys to know is that T lymphocytes are able to recognize a particular type of antigen. I'm explaining this first point. A T lymphocyte will only recognize a particular antigen depending on the type of MHC molecule that has brought that antigen. And that process is what, or that property of T cells being so selective, is what we call MHC restriction. Okay, so that's something you must take note of. Also, the interaction, a B cell can interact with a T cell. A B cell on its structure, it has a point or a molecule on its structure known as a B7.1 and a B7.2 that reacts with on the structure of a T cell. A T cell, apart from it having T cell receptors, it also has a molecule that we call CD28. So CD28, when it meets up with B7 of a B cell, you get the point, eh? There will be a reaction there. There will be an activation reaction between a B cell and a T cell, which I'll talk about in a few weeks from now. That was just a glimpse. Thank you a lot. Any questions? I don't like talking alone. It's better I talk with other people. Might find that I've just been talking without you guys getting me. You see how interesting immunology is, isn't it? Any question? Any questions for me?
No question, Doc.
Or there's just too much that advanced doc. I didn't get you, doc. What did you say?
There are no questions.
I've said a lot. I get you. Okay, yeah. So that's basically summarize everything about adaptive immunity. I want you guys to be connecting. Oh, okay. On MHC, we have two types of MHC: class 1 and class 2. Class 1 is found on all body cells. Class 2 is only found on antigen presenting cells. But take note also that antigen presenting cells also contain class 1. They are the only type of cells that contain both class 1 and class 2 MHC molecules. So class 1 molecules, or let me say class 1 MHC molecules recognize antigens that are indo or endogenous antigens. Then class 2 antigens recognize exogenous antigens. Okay, I hope at least I've summarized that stuff for you, though. So immunology is that connected. I want you guys to be connected like this because yeah, you're welcome. So you have to be connected in immunology like that so that you'll be able to understand microbiology nicely when you start doing microbiology. Because microbiology is going to be, for you to understand microbiology, it depends on immunology. So if you have a bad, if you make a bad foundation in immunology, then to be honest, microbiology is going to be something else. Going to be a very hard journey for you to basically take. So that's how immunology is. So next time you and I meet, I want you guys to go and study ahead. You start, but there is going to be a quiz for you guys. I'm going to tell you when you're going to have it during the week.